In this video, we are going to learn how to do backtracking. And for that, we are going to need one piece of vocabulary, which is inverse operations. Those are calculations that undo each other. So, for example, if the operation was add 6, then the inverse would be to subtract 6. If the original operation was to divide by 2, then the inverse operation would be to multiply by 2. There are other examples of inverse operations, but those are the main ones that we're going to be using in this unit. So backtracking is the process of working backwards from the answer to find an unknown number. So for example, we might ask, what number plus 3 equals 10? So in this case, we have some unknown number that we are adding 3 to, and we're getting 10. Well, what number plus 3 equals 10? 7 plus 3 equals 10. So that means that my unknown number, or perhaps I might call it n, that n would equal 7. And I could check it by saying 7 plus 3 equals 10. Let's try some more complicated examples. All right, so let's say that we have some unknown number, and first we add 4, then we multiply by 2, and finally we subtract 4, and in the end we get 10. Now we could sort of guess and check our way through this, but it's going to be more efficient if we move backwards by backtracking. So if we know that on the last step we subtracted 4 from some number, we don't know what it was, and we got 10, then that must mean that the number we subtracted 4 from was 14, right? We can show that work by using an inverse operation. So we take our number at the top and we do the inverse operation down below. And we know that the inverse of minus 4 would be plus 4. So we're going to write plus 4 underneath. And so what we did there was 10 plus 4 equals 14. Now on the next step, we had a times 2, but since we're backtracking, right, we're going backwards, that must mean that we need to divide by 2. 14 divided by 2 would give us 7. On our last step, which was, of course, the first step in the original problem, they added 4. So if we're working backwards, we must need to subtract 4. And if we subtract 4 from 7, that would leave us 3. All right, so now we think that n equals 3. Now, I might have lost you somewhere in there, so let's just double check that this worked. Let's do 3, and then my first step was plus 4, and then I got my answer to that, which was 7. Then I did 7 times 2, which gave me 14. Then I did 14 minus 4, which gives us 10, which is exactly the steps that we had in the original problem. So my check worked. N equals 3. All right, let's do another one. This time let's go a little bit faster. So I am going to reverse each step. So the last step was to minus 20. So going backwards, I am going to add 20 to give me 40. Then I had times 8 So going backwards, I'll divide by 8, which will give me 5. And my first step was to divide by 2, so my next step will be to multiply by 2, which will give me that n equals 10. Then I will check my work by doing the original steps. 10 divided by 2 equals 5. 5 times 8 equals 40. 40 minus 20 equals 20. I got it. N equals 10. Let's do it again. Okay, this one I'd like you to try and pause and see if you can figure it out by yourself first. Don't forget to check your answer. Did you get 9 for n? If not, look through carefully and see where your work is different from mine. If you need to, go back and rewatch one of the earlier examples. And then when you're ready, go on to the practice problem where you're going to try this one more time for one that we're going to check in class tomorrow. All right, and for your practice problem, you're going to take a number, multiply it by 4, add 8, divide by 6, and it needs to equal 2. Use backtracking to figure out what my number was. We'll check this in class tomorrow.